Hello, everybody, and welcome to the Cisco Community's Expert Series webcast. Today, we're going to talk about the introduction to network design. My name is Hilda Arteaga, and I'm a community manager of the Cisco Community and the host of today's event. Before we start, there's something I would like to share with you. The Cisco Community is an online forum with over 500,000 members where you can get answers to your technical questions prior to opening cases with the tag. Also, there you can answer to many questions, contribute, rate documents, videos, and blogs. So before we start, there are a couple of events, news, and activities that I would like to share with you about the community. Well, firstly, we are going to have an Ask the Expert event following this webcast session. On this space and this forum, you can make all the questions related to this event, and David will be helping us to answer all of them till Friday, December 21st. Let's say that you have a question after this event, 1 hour after, 2 days after, or maybe your question wasn't answered during this session. You will be able to find the answer just right there, and David will be helping you to clarify all the questions. Also, we have a special Ask the Expert event on the global community that's in English. We are going to talk about VPN on Cisco routers. The expert Leonardo Peña will be solving all the questions regarding best practices and configuration. This event is available till this Friday, 14th of December. So if you have any questions regarding this, please go to the community and place that right there, and Leo will be helping you to solve them out. All the events that I'm mentioning right now, then all the information that I'm sharing with you, is available on the channel path of this event. So if you need the link to go to that event, it will be available just right there. And also, for all of you among the audience who are Spanish speakers that you manage the language, we have a special event, and the last one from the year, from the whole community, about cloth and architecture of the last century in data centers of the future. This event will be next Tuesday, on the 18th of December, at 10 hours Central Standard Time. This is a public event available for everybody, and the Cisco champion, Guillermo Ruiz, will be there to share all that information. If you would like to register to this event, it's available on the chat. And also, we'd like to invite you to become an event top contributor, to participate in the community and to share all your knowledge with people. We award people who are helping others, who share content such as documents, blogs, or videos among the community, such as David, for instance. He's a Cisco Designated VIP from the CLN, which is the Cisco Learning Network. And also, many people sometimes just keep asking us, so why should I participate, or what should I do right now, and how can I get awarded? Well, there are two ways to do it, or actually many ways to do it. But let's say that if you go to the community, maybe you are not the one who shares content, but maybe you are making a technical question and someone gives you an answer. Please help us to rate all the content and all the answers that are just right there. If someone gives you a reply that is correct, please rate it as an accepted solution, or please give it a helpful vote. It's very easy to do it. It's just you have to click it on the start or on the square that says accept a solution. And with that, we can identify quality content and people who are doing a great job right there, so we can award them and recognize them in future. Okay, so to start about this session, I would like to talk to you about the presenter that we have today. We are very happy that he's with us. He has been helping a lot in the community, and actually a lot of people around the globe. So his name is David Samuel Peñaloza Seijas. He works as a senior network consulting engineer at Verizon Enterprise Solutions in the Czech Republic. Previously, he worked as a network support specialist in the IBM Client Innovation Center in the Czech Republic. David is an expert interested in all topics related to networks. However, he focused mainly on data centers, enterprise networks, and network design, including the software-defined networking, which is SDN. David has a long relationship with Cisco, and he has been an instructor for the Cisco Academy and was recognized as a Cisco champion and Cisco Designated VIP from 2017 and 2018. David holds a CCNP in routing and switching, CCDP, CCNA in security, CCNA CyberOps, and a CCNA in service provider certification. Thank you, David, and welcome.
Thanks for inviting me.
No, it's a pleasure. And also, we have a great event here. We do not only have this VIP and Cisco champion David, we also have Peter Paluch. He's a CCIA. He's a long-time aficionado of the IP networking, and currently he works as a customer support engineer in the area high-touch technical support team for Cisco. Peter focuses on data center switching technologies, and in his free time, he indulges in all things of routing, particularly in routing protocols, routing technologies, and MPLS-based services. Thank you so much, Peter, for being with us today. We hope you enjoy a lot of this session, and Peter will be helping you to clarify your questions as a question manager.
Hello, everyone. So happy to have you all here. Welcome.
Okay, awesome. For all of you who would like to have a deep look into the presentation, I would like to double check everything that David is just sharing with us today. You can find this presentation on the community. The link to access to it will be available on the chat panel just right now. And also, for all of you, in the meantime that David is presenting, we also have Peter will be helping out to clarify your questions, so please don't be shy and make all your questions at all times. We will do our best to cover most of them. And please use the Q&A panel to make all the questions related to this session instead of the chat. Through the Q&A panel, we can answer and manage most of your questions easier. And please use the chat panel just for all the logistics and all the questions that are more like particular, like I don't have audio, my screen freeze, or I would like to contact David or Peter or the community. Please use the chat for that, and the Q&A for all the technical questions related to this session. And finally, we have a new WebEx, just as a reminder, and for all of you who haven't tried like the new version. So just make sure that on this new WebEx you are picking up, there's a drop-down menu just at the middle of your screen, and just like pointing out on this slide. So just make sure that you just pick up the one that says David sharing screen. So in that way you can follow up the presentation. And well, that will be all from my side. And now I will pass on the microphone to David so he can continue his presentation. I thank all of you for being with us today, and I wish you'll learn a lot from this session, which I'm sure you will. Thank you, David, and please go ahead.
Thank you, Hilda. Once again, thanks everybody for joining here. And in today's presentation, what we are trying to bring to you is the mindset and the design principles that are really needed when we are approaching the network design process. This is going to be an introductory session where we are covering generic terms. We are trying to have a wide scope, but at the same time, we cannot go that deep as, well, design on its own is a huge topic and a huge matter just to cover. But we are trying to do as much as a comprehensive introduction as we can. We're trying to make it not so cumbersome, so there are maybe some things that could be explained in a simple manner, but nonetheless, we encourage you to do all the questions, and Peter is here just to give us a hand with this. So, well, once again, thanks. Well, let's get started. We have a polling question, and you'll have a menu on your right side, if I'm not mistaken, so feel free to pick the choice you believe is the right one, and we can be discussing all the outcome of the polling. Okay, so the agenda for today, we're gonna give a brief introduction. Why do we need the network design principles? Where can we apply them? Specifically, what are them? Okay. How do we take these principles and then we apply the mindset, the so-called mindset, which is a different way of seeing things, of analyzing the information we are given, and come up with a proposal. And this proposal needs just to fit into what are the needs of our business, what are the needs of our customer. So we are going to speak about these principles, the mindset, and then we are just putting everything together. We are having a couple of scenarios that are just tailored for this session that were just made for this. We're going to discuss them briefly just to give you guys a hint at how can we analyze this information and how to approach them. And after that, we are going to just have a couple of conclusions about all the topic, and I'll call it a day. We are going to have if I remember well, live questions after all the session. So now beginning. just as a brief introduction, right? What are the common scenarios we are seeing that are seen in networks? We're having networks that are unstable. That are unstable because they have grew too much, because they were not properly properly planified. They were just improvised. We were just trying to make it grow because everything was just in a rush. Then we were just plugging cables one next to the other. All the lights were green. Let's go home. It's working. This is a common example of what happens really in the enterprise environment, not even the enterprise environment, but in general. This happens quite a lot. There's a lack of compliance, as there is improvisation, also there's a lack of hierarchy. The network tends to be complex not only to understand, to troubleshoot, to even manage. So, as I was saying before, we have these common scenarios that are seen in networks, where I already explained the instability due to the organic growth. It's just improvised. It's not having a correct program. Is not being really it's not being measured on over time, and it's not being scheduled and not planified. So due to that, we have the lack of compliance, of hierarchy. The network just grows complex and grows without any kind of structure, right? We are just plugging things to make other devices work, and well, everything is working, so we can just go home, and there's no real planification. And for sure, this is not aligned to the business goals, because it also happens from time to time that there is a network implemented, and somebody just makes a marvelous and beautiful solution with all these fancy words. Everything is automated, everything is having amazing throughput and blah blah blah. But then the customer is not enjoying it, because simply this is not what they needed. We not only need to deliver technologies working together just to achieve a goal, but we need then to achieve the business goals. We need to provide the customer what they need. Sometimes it's not the fanciest solution, sometimes it's not the latest of the codes, it's not having all the functionalities, but it's what they need. So we need to avoid the gold plating. We need to avoid the over engineer and overdoing it, because there is a specific solution for each case. Whatever is worth doing at all, it's worth doing it well. So just talking a little bit about network design principles, we are going to cover reliability and resiliency, which are closely tied to redundancy, modularity, which is related to how do we have a scalable network, how we increase the manageability, how do you make a network which is simple and flexible at the same time, how availability is measured, what is availability, what is the fault isolation, why we need it, and lastly, what is hierarchy and how we implement it. So starting by availability, this is a really interesting term, because availability for us, for the IT people, would mean something, and for the users would mean something different. For us, for the IT people managing a network, availability would be checking failovers, monitoring devices, having a specific number of times when the links go up and down, the bandwidth that we are using every link, if the network is overloaded or not, the number of failures that we have. But for the users don't see this. For the users, what is important is the experience, the availability of the service. So for us, could be the availability of all the devices and all the graphics and all the metrics. But for the users, is how fast am I loading my web page? How fast my application is responding to me? Why I cannot share this Facebook status, right? This is very common. So just as an analogy, we have as we have different let's say taste, it's precisely the same with availability. So you would have for instance, you would have a singer who is singing pop, and you have another singer who is singing country, maybe. So not everybody likes country, not everybody likes pop. There is an audience for each one of them. It's exactly the same. Availability will have a specific way to be measured depending on which side of the fence you are. But ultimately, it's how do we keep all the services up, and how do we keep the network up? Because the final objective of the network, the reason of being of the network, is to provide service to the users, to provide connectivity, to be a transport. So how do we increase the availability? The availability is increased by means of redundancy. Okay, not only, okay, by means of redundancy in which way? First of all, what is redundancy? And needs to be clearly defined, as it's not exactly the same as resiliency. Redundancy is the way we can implement our design, and having multiple paths, boxes, links, setups, configurations, which allow us to be ready in case of a failure comes. So we are just having a backup path, we are having a backup device, a backup link, which is not necessarily being used all the time. It's not being necessarily used right now, but it's going to take over completely should a failure happen. So and lastly, what is the scenario when the failure happens and the network recovers? This is called resiliency. Resiliency is the ability that the network has to recover after a failure happens. So we will increase our availability by means of implementing redundancy, and therefore allowing our network to be resilient. All of these then would lead to reliability. The network is available, the network is resilient, the setup is redundant, therefore it's reliable. I can be sure that my services are going to be up. I can be sure that they will be all the time up. In the same way, we are always sure that, well, when we open our map application and our mobile phone, it will be working. Whenever we are opening, I don't know, Netflix, it will be working. We are sure that the network is going to be up and our services will be there. Therefore, we see it as reliable. And for us as users, this is what reliability would mean. This is what availability would mean. So now jump into the next of the principles. We have modularity. Modularity is closely tied to several other principles, because by means of modularity, or by applying modularity, we can allow the network to enjoy the positive outcomes of this. So first, what is modularity? Modularity is the way that we can divide, we can build the network in smaller pieces. We create modules, we create sets of boxes, set of devices, set of features that are working together to achieve a specific goal. The main point here to understand is that this module is going to contain specific fixed pieces to carry on a specific function. And then we are just going to assemble our network having several modules working together. When we implement modularity, then we can allow our network to just enjoy, or just to get the benefits of scalability, manageability, simplicity, and flexibility. If my network is easy to grow, it's easy to build, it means it's simple, it's scalable. And we need to understand that scalability is not the same as growth. Scalability is it's the capacity of growing without growing the network without affecting all the other services that are already running. Which means that if my network is just scaling, it's growing, I don't need to feel that all the throughput or all the quality of all the performance that I have in the network is going to be affected by this. Now, talking about manageability and simplicity. When my network is not only easy to grow, easy to scale, easy to build, it's also easy to manage. I know in which core each function is allocated. I know what is happening in every part of the network, and I know where to look for if something is failing. The fact that the network is having an increased manageability, it means that it's easy to manage, or at least you can manage it in a better way. It means that then it's also easier to be supported. So whenever we have an increased manageability because of the simplicity of the network, then we are having supportability. We need to also keep in mind that when we are designing the network, yeah, we are delivering an amazing solution and everything will have fancy lights and will be cute and super modern. But also we need to think about the people who is supporting it. If you're an engineer who is implementing it, you don't necessarily will be supporting it. So is the people that is going to be supporting the network being able to handle this? Are they going to have the right skills for this? So you need to also think about the supportability and who is going to take this over after, well, after you design it and implement it. In the same way, we can make the network grow because of adding modules is also allowing us to be flexible. Whenever I can make the network grow just by adding a new module and another module and another module, and then if I need a functionality, I need to have remote connection for my users that are mobile workers, then I will just add a new module to the network, having all these functions there configured, and I just connect it to my distribution module, to my core module. If I need to have another specific function, I will just add another module. That allows me to be flexible because scaling network, adding a new service, including a new application will be just a matter of having another module. Of course, there will be another considerations to make, but the fact that the simplicity will allow you to do this in a less cumbersome way, it's giving already a positive point to consider. So how do we see the modularity in action? If we just start building with modules, we will have something like this. Assuming we have a campus, and one of our buildings is having a couple of switches, right? A couple of distribution switches. They are working together to provide redundancy to our users. But what if, well, now my campus grows and now I have another building, right? Okay, I will interconnect the buildings, then it will be 2 links per switch to the other switch, and well, it doesn't look that complex. But what if I then need to add another building? Then things will start to get a little bit more complicated, because then I'll need to connect every building with the other buildings, or every switch with the other switches, to make sure that I am keeping the same values of redundancy and resiliency, right? I need to make sure that all the other switches are reachable from each switch perspective. But what happens then? When the size grows, the complexity grows too. We will have a high number of connections, it will be expensive, and it will be complex. So how do we solve it? Again, modularity saving the day. If we, at least in this specific case, it's a very simplistic case, but it was the way to just explain it, well, in a not so complex way, right? In a simple way. So having the 3 buildings, before we had to connect them between them, right? But now that we are having a specific module that is taking over all this, and a specific module whose function is to be the core, is to provide the transport of the packets from one point to another point. So what are we going to see now? That we can only use the same number of connections we were using in the past, but we are just going to the core instead of the other switches. So we are having less number of connections, less number of ports, at least from the other switches perspective. And at the same time, we are just prepared for, let's suppose we have another building in the right side. Then we are totally ready to add another building, and will be totally seamless. We will not have to touch all the other devices to add another building. Because if we have interconnections with the other buildings, then when we are just adding a new element, it doesn't have to be buildings, right? Adding a new element means then touching the other devices. When we have this model in the core, then everything is just going to affect the core. We are just only touching the core module, and that will be all for us. So we are also reducing the potential to have a mistake, to have an error, to bring the network down, because there's simply an action that shouldn't be done and it's done. So the core module will reduce the amount of connections and design complexity. Another very important principle, it's fault isolation. Why do we need fault isolation? We need it because when we are having a network which is working all together, it means that the failures could affect all the elements composing this network. Well, not supposing a network, all the elements composing this entity. So as an easy example, right? An example we can relate to. Assuming we have an OSPF area, and this is an example well known to all of us, right? If we have a failure in one of the devices, and this is a single area, then what is going to happen? All the devices in the same area are going to recompute, they're going to recalculate, they are going to reconsider that there was a device down. Then we have the stages of the convergence. We have the fault detection, we have the event propagation, then we have the recomputation, and then we need to add all the details to our routing table and our forwarding table. All this process not only takes time, takes resources, and causes instability. When the network is just recalculating, when all the devices in the same failure domain are recalculating, this is causing instability. This is causing a loss of traffic. So if we have the same network, right, but now we are going to implement 3 areas. We're going to isolate all those failures in a specific area. Each area is going to have topology information that is going to be only shared with within the area. So all the devices in area 20 know about all the devices in area 20, all the devices in area 0 know about the area 0, and area 10 knows about area 10. So if we have a failure, we are going to have something like this, which is totally different, right? We are having the failure, which is, as you can see, encapsulated, is just limited to the area which is happening. So if there's a failure in area 10, then only the devices in area 10 will really know that this happened. And this is a very important principle we apply in networks when we want to scale, when we want to hide the information. We want just to prevent that a failure in one part of the network is going to cause a problem in another part of the network. We don't want somebody to press a button in one side and then 1,000 kilometers away, somebody else's, light will just go down. This is pretty much what we are trying to achieve. We are trying to contain these failures. And lastly, as we contain the failures by decoupling the networks in several pieces, in several parts, in several smaller failure domains, we do the same with hierarchy. We just separate the network in smaller zones or smaller layers and smaller groups of devices. And each one of these devices is going to perform a specific function. The main idea of this is that we are not going to have one device doing everything, because also we would have a single point of failure. Then we can just divide the functions among several devices, and then we know which device is performing what. We know the firewall is performing NAT, or we know which switch is being the spanning tree route, for example. And we can have hierarchy in several levels. We can have 2 levels of hierarchy as in the left side. We can have 3 levels on the right side. We can have 2 levels of hierarchy. It all depends of what do you need, right? So as in design, something we need to consider is that everything is just based on the right proportions, and everything in design is based on a trade-off, which means that if we increase our scalability, as an example, our manageability will go down, simply because it's a bigger structure, it's more complex to maintain, it's more complex to manage, it's more complex to understand. If we increase the resiliency, we increase the redundancy, which means adding more boxes, adding more features, adding more links, adding more bandwidth in the links between the devices, then that means that the complexity also will increase, that the cost will also increase. And in an analogous way, if our flexibility increases, when we increase the flexibility too much, then the network is hard to manage and is growing complex. There is a point in flexibility when it becomes a burden. If we have a network which is flexible enough to be able to just accept or be able just to be expanded, adding new services, is being flexible. But if we don't keep a hierarchy and an order, then we can just plug everything into any random device and another module here and there. And what are we going to have? We're going to have something which is hard to understand, complex to troubleshoot, complex to manage, and it's even complex to go through, right? So we have a polling question. We have a second polling question. We encourage all of you to participate. And this time, what is the main goal behind the information hiding? And I do believe I was talking too much before. So, totally up to you guys. And I will not click the polling question this time because I don't want it to crash. So, network design mindset, right? We have spoken so far about what are the principles. As a technical person, you would understand what are these principles, right? Why do we need resilience? What do we need redundancy? Why the network is scaling? But how do we implement this principle? How do we know when and how implement it? How do we understand that there is a specific moment to discuss about this and to do it? Because as a technical element, as a technical person, we are having some specific mindset. As a technologist, we are a person who understands about functionalities, features. What do we do with these two devices? How two protocols work together? How I redistribute between OSPF and BGP as an example, right? And we have the other side of the road, which is a business thinker, which is the person who needs to understand what the business needs. Maybe the business doesn't need a higher level of redundancy. We don't need to have, 6 power supplies and 10 line cards of 48 ports, because we don't need that much resiliency. We don't need 4 routers. We need 2 of them. We don't need 4 switches. We need 2. Yeah, there's a degree of resiliency that maybe we could need, but this is something you can determine if you have the correct business thinking. What is the business needing? But then what happens when you get the business and the technology together? Then you will get a designer. You will get the person who is able to understand technology, who is able to understand the business needs, who is able to help them to achieve their goals by means of translating this information into technical requirements. Because the business says, I need an environment where I have where I can share an infrastructure, and then you simply would make a functional requirement of this, which is okay. You need then a multi-tenancy, right? Then our technical requirement would be having the ability to share an infrastructure and isolate all the users in the same infrastructure, right? So we can just get from business requirements down to a technical requirement by just having the right thinking and being this bridge, right? Because the designer will be the bridge between the business and the technology. So what are these, speaking about the mindset, right? The elements about the mindset. Having the network design mindset means that you are able to observe the big picture, that you are able to ask the right questions, and you are able to identify requirements and constraints when you get the right information. This is not an easy task. This requires not only a lot of practice and experience, because this requires also a little bit of patience. You will not always get all the information from the business, and then therefore you need to know which questions to ask. So speaking about design mindset, I'm going specifically for observing the big picture. You will have surfaces of interaction. Where are the protocols interacting? Where am I, for instance, redistributing? Yeah. Where are my routing domains? How big are my routing domains? How small they are? Do we have more than one routing domain for any reason? Are we hiding information? Where are we summarizing? Where are we aggregating? Yeah, where are we having sites being stops? Where are we isolating one part of the network for another? Where are we just decoupling the network in pieces so the failures in one side don't affect the other side? We need to observe the inner mechanisms, the pieces fitting together to compose this ultimate puzzle. Where is my LAN, my WAN, my DC? Do we have a cloud? How do we use the cloud? How all of them are really composing this landscape that we can call the network infrastructure. You need to identify the application. Okay, and the application, with application I mean the service. It could be a specific application that you have, or it can be a service you are providing. But at the end of the day, the network is there to provide a service to all the users that are connecting to it. This is its reason to be. What are the current and future traffic patterns? Why? Because if you are getting, or you're given the opportunity to participate in the design of a network, then you need to understand that in 99% of the cases, you're going to have a brownfield environment. You're going to have an environment that was already existing. You are going to have an environment that had already requirements, or environment that was already running applications, having services on top. So you need to understand how the environment is behaving right now and where I want to get it once I do my recommendations to, well, to improve the design. And listen to the business. What do they have right now, or what do they think they have right now? Because most of the time it happens that the business is not having all the information you need, or at least it's not that easy to obtain. Right? So what do they want? It also sometimes happens that the people in the business don't know really what they want. We can just get a random email from our VP saying that, well, our CEO went to Cisco Live and then suddenly realized we are not running IPv6, so we need to run IPv6. Then the question is, do you really need it? Why do you want it? Are you going to run a service on top? What are you going to do for it? Of course, well, we need IPv6. Come on, the IPv4 is a legacy protocol, but this is just an example. So do they know what they really need? What is the geographical footprint? How big is the company? How far are the offices one to the other? Is there something in one continent? Is there something in Asia, Europe, US? And how they plan to grow if they are planning to do it, right? They are planning to just increase their presence all over the world. They are planning to increase their presence only in one continent. They are planning to do what? This is what we need to understand from the business perspective. Now, this is the part where we already got some information from the business, but we don't necessarily have all the information we need. So what do? We start our process of asking the right questions and finding the information. We are trying to find all the hidden requirements, all the covert requirements. We might have a customer who says, I'm going to expand my operations to Asia. But are you considering then as a requirement that in Asia, as an example in China, you would have specific constraints around having encrypted traffic? Maybe this is not an upfront requirement. This is not something mentioned at the beginning, but this is information that you can get after you get the information from the business. So how do we ask the right questions? We start by the what. We start by what is the current state of the network? Is it redundant? Is it stable? Is it scalable? Is it resilient? Is it compliant with the corporate policies? How is the network right now? How is it behaving? How big are the failure domains? Are we having a flat OSPF area? Are we having a flat EIGRP topology? Are we summarizing? Are we having a block of IP addresses that we can summarize? Was this planified? What are the pain points? Do we have single points of failures? Do we have devices that are out of support? Do we have functionalities that need to be migrated? Do we have all one circuits, ATM, frame relay, all these technologies from 20 years ago? Are still your services being supported? Are your devices being supported? Are you having devices that at the end of the day can fail and then you're going to go to the vendor and get a replacement? You probably not. So what are your your pain points, and how big is the network? Are we just decoupling network in pieces? Are we just having a big cake? What do we have? After we go through the what, now we need to understand the where. Where is this information hidden? Where can we optimize all the network that we are seeing right now? Where are the points where your infrastructure can be optimized? Where can we apply functionalities, features, configurations that can really increase the throughput, or that can increase the performance, that can make easier the manageability? How can we make it better? And where are the surfaces interacting? Where are several learning protocols working together? Where is my L2 infrastructure ending and where is my L3 infrastructure ending? Do we have a routed access? Do we have a common a coarse distribution and access model? Do we have the spanning tree roots in a distribution switch? Or are we using spanning tree at all? Are we using class fabric? What are we using, and where are the protocols working together, simply? Okay? And after you got the what and the where, now we need to know the why. Why was this deployed that way? And this is one of the questions that it's multi-level. You need to ask the question several times. So as an example, why was this functionality deployed? Because we were having problems with stability. Why were you having problems with stability? Because we had a very big failure domain. Why were you having a big failure domain? Because, well, we didn't planify properly and divided it into pieces. Why you didn't planify this? Well, because we didn't have the knowledge about this, or because these features were not supported, because of whatever the reason. But when we need to ask the question more than once. This is a multi-level question, and it's really convenient to just keep asking till we get to the root cause of this. As a last point, you need to identify the requirements and the constraints based on the information you're getting. What is the goal of this design? Yeah? Do we want to offer a new service? Do we want to add a new application on our already existing infrastructure? Is our company big enough to merge with another one? Is our company big enough to divest itself with another one? Are we having a startup and then suddenly we are getting absorbed by a bigger company? Are we being bought? Then this is what we need to understand. What is the goal? Do we want just to scale the network? Do we want to optimize it? Because right now it's working well, but we want it to work better just because we have a big project that we need to take, and the network must be ready for it. Which I really wish would be always the case, but no. So what are the applications or services requirements? Do we need short convergence times? Do we need to adequate our transport so we have a specific application having jitter, delay, and drop sensitivity? Apologies. Is our application or our service needing L2 adjacency? Is it requiring multicast delivery? Is it requiring optimal routing? Can we just do hot potato routing or versus cold potato routing, which is optimal routing versus suboptimal routing? Do we want to get it from point A to point B, or do we need to send it through specific points in the network? So what cannot, must, and must not be done. And with these, we refer to things that could be optional and things that are mandatory. And this relates to regulations, data encryption, data storage. Are we going to keep the records of our patients saved for 3-5 years? Do we have to encrypt them when we are saving them, we are storing them? Do we need to harden the devices? Do we need DDoS protection if we are a service provider, for example? Do we need to train our internal staff? Can we do it? Do we have the budget for this? So if our internal staff is not really having their desired level to support our network, then we need to implement a simple design. Just because having a complex design will just not help to having a proper support. Do we have a specific protocol choice? Are we just this kind of company that only loves Cisco? Are we a company that wants to use not only Cisco devices, but we want to use any other vendor? So are we having a specific protocol choice, or are we just totally open to any protocol coming? Are we just with one vendor, with any vendor? Are we open source? Are we privative? And lastly, how and when. Once we understood what do we have, where do we have it, why do we have it, and specifically what to do and what to not do, then we are ready to know how and when. Are we going to do a plan outage? Are we going to do it through a forklift approach, which is pretty much just light everything on fire and start over, right? Or are we going to have a phased approach? Are we going to implement IPv6 slowly, step by step? Then we can have a phased approach. Do we need Or do we require minimal service disruption? Are we providing a service to our customer? Our SLAs are already tight. Are we going to pay a fine? Are we going to have legal repercussions if we breach an SLA? And very importantly, making before breaking. I need to make sure that the infrastructure I'm building, it's working, it's there before I am dropping the previous infrastructure in case I am migrating, for example. So it's not only important to know what to do, but how to do it and when to do it, do a proper planning. So now that we understood that already, we discussed what are the design principles and what is the mindset. So how about we put it all together? So in this section, we are going to have specific scenarios that were created just for this. These are scenarios that I have written before, just to demonstrate in which way we can understand how to analyze the information we are given to us, right? So we have we have a company, a marketing firm. We have a brief introduction about them, right? We have information about them having a goal. They want to do something. They want to take the next step to modernity. They want to optimize their network. They want to have a new application, or they are going to prepare themselves for something new, for a new service, right? And was their network prepared for this, or maybe it wasn't? There are current problems. Do we know what is happening there? So this is what we need to find out. So for a common, how to say it, when you get all this information and you apply the mindset, right? You apply the principle, then you understand what we could do, but then you need to ask a little bit more of another question, right? We need to get more information to know exactly what we need to do and how we can do it. But we have an introduction. So how do we analyze this information? I'm not going to go through all the info. Well, I mean, if we can just share the slide later, because there's a lot of information to consume. But just as a test, this is what we would see if we would just take in with detail only the specific information we need. So for us, then it needs to jump to our eyes that, okay, so they provide collaboration solutions. Oh, they want to take the next step to modernity, polish the rough edges in their network. They want to have a new website, rising the amount of customers. So the network, well, it grew quickly. It's not working as expected. We are having instability. See? So now we get all this important information and we just put it together to understand what do we need and where do we are, right? So when we extract the key information, then we get the collaboration solutions and the next step to modernity and all the phrases we have already mentioned. So now this is the moment when we ask the questions and where we understand what do we have. So if we go one by one, we get collaboration solutions, and then my first question would be, is there QoS implemented? We have video, we have audio, we have voice there, right? Is this implemented? Can we do it? What is our design goal? Well, according to them, they want to take the next step to modernity. So this is their goal. When we read about polish the rough edges, then we see that it's about optimization. They want to make it better. Launch a website would mean hosting a new service. Where is this service going to be hosted? On-premises, on the cloud, on a DC. Where are you going to put the service? We got the information that the network grew quickly, which means organic growth. Rise in the amount of customers is what they are expecting, which means that there is a future growth. There is a scalability needed in our solution. In what are we going to prepare for them, right? The working is either not working as expected, is flopping inexplicably, so we have instability, right? Few members in their staff are having limited knowledge, which could lead to lack of standardization, and also the need to just recommend a simple design. We have a lot of OSPF, we have a float war, then this is the current state of the network. We now know what is there. How do we fix it, right? They do not know which protocol to use, then okay, let's just compare and contrast the options. What do they need from a protocol? They need granular path manipulation, fault isolation, How are the offices connected? Is there any regulation to encrypt the traffic? So the main idea here is ask yourself and the business the right questions, and also understand the information once you're getting it. Okay? So let's go to a second example, and this is our last example for today. This is a company, a web hosting company with a very cool name for all the of the Linux aficionados. It's a company that started with they began having storage, they began having web hosting services, and now they are ready to jump to the next step. They're ready to go to the content delivery network space. They're ready to compete there. So how do they do it? How they're going to do it? They want your support on this. They have some data centers, they have some running services already, and also they have previous experiences with attempting to achieve these goals. So where is our information? There you are, web hosting company, massive and complex. Storage services, website and email hosting, incursion to the content delivery network. So let's extract all the information. And there you go. If we have a web hosting company, then where is the service being hosted? The company is massive, it's complex. So do we have a slow convergence? Which routing protocol is implemented? Is the routing protocol able to cope with it? Is right now the infrastructure stable? Right? What do they need from a protocol? Ingress load sharing, flexible traffic policies, low delay and jitter. They're trying to do an incursion into the content delivery network world. So then you need what? You need to just to get the information for your customer, to catch all the information for your customer and get it ready for them, so they are able to feel the benefits of having a content delivery network. For the content delivery providers, their main goal or the important goal is not only be, of course, in specific points of the globe, but also be able to provide the service to their customer through the ingress load sharing. It's fairly complex to perform ingress load sharing as opposed to egress load sharing, because you always know where you're going to send your traffic out, but you cannot easily just determine where is going to be your ingress flow. So for CDNs, this is a key factor. Do we need then flexible traffic policies? Do we need low delay and jitter? What do we need? Is there a QoS there? Expand their footprint means future growth. Ready to invest in the infrastructure means, we are not going to have budget limitations. We're going to have optimizations. We are ready. This is a customer who wants to invest. But the following months are going to happen in a very rough manner. We need a quick deployment, which means that we cannot just decide for a solution where where it will take time to implement it. We need to find a way to implement quickly and efficiently. They want to get most of the attention. That means that we are going to get high scale. Our solution, our recommendation is to consider high scale, needs to consider a high amount of customers, of service, of traffic. Their main goal is to expand their DC. So we have a goal there. It's not always that easy to read the goal, but well, in this case, we just made a cool example about it. The network must be highly available. They need to be not only available always, but also everywhere, which means no downtime. They had before fines paid to customers. They had an SLA breach before, and they had to pay a penalty for this. Then the downtime is something that needs to be considered in our planification. They made some previous attempts. This is the last chance to do it. So we not only need to be careful, we need to do it well. We need to go step by step and minimizing the downtime minimizing the downtime as much as possible. Apologies. Okay, so now we have to our third polling question. Which information limits the scope of the available solution, right? We are having a group of solutions. We are having a wide scope. And then we are having what? What is limiting my solutions? If I have a series of options, and then I need to have a specific requirements, then what is going to to make this scope smaller? Well, I can give you the answer though. the constraints are going to make my scope smaller. Because assuming you have a big circle, which is your scope, your constraints are going to be figures inside the circle, just limiting the amount of the scope you can take. So as conclusions, just to close up, we would have to think about how the defaults can affect your network and build them so they are ready when the event occurs and they can act accordingly. So implement redundancy. In this way, you're making sure that your network is going to be resilient, is going to be ready for anything that is coming. There is no universal design. There is no one size fits all that will apply for all the cases. Everything will depend always on the requirements and the constraints. The ideal design would meet the requirements that the business is having within the constraints. But to identify the constraints and the requirements, then you need to ask the right questions. Once you have the right information, then you need to start to compare and contrast your solution. What is the best way to do it? And also keep in mind that there is more than one way to solve a problem. There's not only one solution. There could be many of them. Very important. The best solution is not the most advanced. It's not the most expensive. It's the one meeting the requirements and adapting to customers. So avoid the gold plating. Well, this is the last of the presentation. Well, the last of these slides, should I say? And well, thanks everybody for paying attention and for not telling me to shut up. So thank you. I hope all of you have enjoyed.
Thank you so much, David. Yes, even though like we had some issues at the beginning, and now things are well. And for all the audience, and for you, David, and Peter as well, thank you so much for this event and for this opportunity to learn more. And for all of you who cannot stay, the recording will be available in the upcoming days on the event page. That means on the page where you register for this event. So right now what we're going to do is just, I'm going to read aloud some of the questions from the audience to you, David. And for all of the audience, just right there, if you have any questions, please place it on the Q&A or on the chat so we can read them out. So David and Peter can help us to reply to all of them. So the first question, David, will be, how important is to have the right mindset to be a network designer?
Well, I would say that the mindset is one of the hardest things to do and one of the most important ones. It's a common story, or it's a common or well-known fact that people, and this is a very specific example, people going for the CCD exam, right, which is the one that well, at least me as a designer I'm pursuing, right? People having 2, 3 CCIAs, they are anywhere finding that they fail. Why? Because you need to be well versed in technology, but at the same time you need to have the right mindset to understand. Because us as technologists, as engineers, we will just jump in and implement the fanciest features and we can do this and this and this because it looks amazing and I like it this way. But maybe that's not necessarily what the customer needs. So the right mindset will allow you to understand what your customer needs and just tailor the network and the design to what it's really meant to be for them. If you go to the tailor to get nice pants and a suit, you're not expecting to have a dress whenever you're going to pick it up, right? It's pretty much the same.
Oh, okay. Thank you very much. I know you already have spent quite a lot of time trying to tell us more about the mindset, but still there are some questions related to your presentation from what you have mentioned before. So another one will be, how can you use the network as an enabler for your business?
The network becomes an enabler of your business once you are helping the business to achieve their goals. If my goal as the business is to provide service to my customers, let's suppose I'm a service provider, right? So for a service provider, their goal, their main service is to provide transport. If I am building the network, if I am preparing and configuring the network, implementing it in a way where the service I'm going to provide to my customer is going to be the best. As the service is my goal, then I'm using the network to be an enabler. Of course, this is a very specific example, but supposing you have a specific service to a customer that doesn't need to be transport. You are having a specific application. You are a startup, create an application. Then you need to then prepare the network in a way that this application or service you are providing will perform in the best possible way. Because this is what you want to achieve, the best for your customers, supportability, to be responsive, to be prepared for their request. Because at the end of the day, you are the business, and the business right now is being supported by the network.
Okay, thank you very much, David. And I would like to remind to all the audience, if you have any questions or something you would like to clarify regards network design or anything that David has commented just during this presentation, this is the moment. Please share with us your questions. We also have another one that says, do you have what it takes to become a network designer? And this is something that the audience has been asking even in social media when we promoted your event. So in your opinion, David, what would be like the points that you need to become a network designer?
Well, this is really a tough question, though, although we were promoting in social media. But to be a designer, you need to have not only this technology thinking, but a business thinking. I know it's a little bit rough, and for the people that working in IT, sometimes it's not very easy just to face the customer, to discuss, to talk, to be open to suggestions, to share your ideas. This is part of what will make you just grow as a designer, because at the end of the day, the designer is the person who will be facing the customer, who will be understanding the customer and speaking business. But at the same time, you need to know technology. So it's like being in the middle of both domains. And it's really, really a complex position. I honestly do believe that I need to keep studying and growing and working on it, well, to be better and to be the best guy at it. But I also believe that this is a journey that it really takes time. It really takes a lot of preparation, not only in the technology side, but also in the business side, in the human side. It's not only about understanding how everything works, it's also understanding how you are going to communicate to all the kinds of audiences, regardless of their technological level, and speaking their language. You need to know your audience. You need to speak business to the business and technology to the technologist, right? There's really a little bit of both in that. I don't know if that answered the question.
Yeah, indeed. I mean, there's a lot of things to consider there. But from what you mentioned, there's a question that someone just recently posted, and it is like, what strategies can you recommend to communicate technical design to non-technical business leaders, that is, the decision makers?
Well, we usually, when we're having this kind of discussions, we go straight to what business understands. Revenue, strategy. These are some of the common ones, right? But how do we do it this way, right? We get to the pieces and we have a proposal, but what is this proposal? What is this proposal going to achieve from the business perspective? We know that from the technical perspective, we are going to have more redundancy, more resiliency, and da. But how do I tell the business that this is going to be the best for them? Then we need to start speaking their language. Example. By having high availability, you are then reducing the possibility of having any kind of breach in the SLAs, which will save you from paying fines to your customers. By having redundancy, then you are reducing the possibility for having any kind of downtime. And we know that in networks today, downtime means money being lost. Time that we are not communicating is money lost. So what we need to do is just speak their business. What are we going to achieve from a business perspective? Are we going to have a higher amount of customers? Are we going to deliver a better service? Are we going to make a difference? Can we just deliver a new service based on this proposal you're doing? Are we going to find any kind of niche in the market that somebody else is not exploiting right now? Can you do it? Then bring it to business.
Okay. Yeah, I think that's a great feedback. Then we have another question here. It says, should security be thought from the beginning while designing a network?
Sorry, again?
Yeah, I mean, if you have to consider the security since the beginning, in the meantime, or while you're designing a network.
Well, I do believe that we always need to secure the network. Well, you would have the common best practices for it. You need to harden the devices. You need to implement protection so your services are not affected when you're being attacked. Assuming you're being attacked from outside, you need to implement security on the access level so the users having any kind of infections are not just spreading it all over the network. You have a minimal or at least a common best practices that you need to apply. And from that point onwards, then you need to consider specific details. Like I'm having an insurance institution, so I need to not only have security, but have a very tight security. I need to have specific access and authentication for a specific sections of the network. It really depends. I mean, there's a common line where you're going to be most of the time, but if you have a specific security requirements, this will depend on the company. This will depend on the business. So you need to always consider it. I mean, maybe it looks like we don't, but we need to. And right now, having all this news about data breach and the information being leaked, then we understand that the security in the network is as important as the ability to just transfer the data through it. Because it doesn't make sense if we are transferring the data through the network if we are just doing it in an insecure way, because then whomever can eavesdrop it. So of course we need to consider it, but there are common lines, and then we can just go about to specific details. Peter, would you like to add anything?
Peter? No, thank you, David. Sorry, just needed to unmute myself. I think it's pretty much covered up. Thank you.
Okay, awesome. Thank you, Peter and David. So then I will be reading aloud one last question so we can close down this session. So in your opinion, David, what are the best tools that can assist a network designer?
Well, a lot of thought, but a lot, really. An open mind. You need to always be prepared for, and maybe this is not going to sound good for everybody, but you need to always be prepared to be wrong. As said before, there will be several ways to solve a problem. There will be several ways to get to a specific goals, and will not always be yours, or maybe not. Maybe yours will be not the simplest one, or the easiest one, or the fastest one, right? The good thing about design and the way that you study design is that you get different optics, you get different points of view, and this is what will enrich your tool set, because you're getting the experience for some other people. The experience is really important to become a great designer, because then you would be facing situations that somebody else did, or maybe that you did in the past. But if you can learn from somebody else's, then that will be perfect, because you have a little bit of everything, not only what you saw, but what somebody else was able to share with you, what somebody else was able to teach you. So you need to definitely have an open mind and be ready for what is coming. A lot of patience and a lot of hard work.
Okay, thank you so much, David, and also thank you, Peter, for everything, and for people who are sending like a greetings message as Merry Christmas and Happy New Year. Thank you as well. And yeah, that's very nice and kind. So well, with that we conclude the live Q&A. Thank you very much, David and Peter. For the audience, the recording for this session will be available in the upcoming days, and for all of you who registered and attended this event, you will receive an email once it's ready, and you can find more information right there also. And once again, if you have further questions regarding this event, you just can post them as the Ask the Expert event following this webcast, where David will be answering all the questions till Friday 21st. And also, if you would like to learn more about the upcoming events, activities, and all the things that are having place in the community, and with the Cisco VIPs like David and Cisco Champions, you can find all the information on Twitter. We are on Facebook as well, on YouTube, and on LinkedIn. And for all of you who have the Cisco Technical Support application, there you can find the information as well. You can find the links to these social media channels on the chat panel, and also for the Q&A. For the Ask the Expert event. And for all of you who speak a different language rather than English, then you can find events like this in Spanish, Portuguese, Chinese, Japanese, and even Russian. So feel free to double check these local communities. And also, if you are looking for further IT training and you would like to learn more about technology and Cisco technologies, then double check everything that the Cisco Learning Network is offering just right there. There you can find more webinars like this. And finally, for all of you who have been participating and for all of you who fill out a survey, you will be receiving a 35% discount on any Cisco Press title that you wish. So please help us to fill out this survey, and you can redeem a 35% discount in any title that you are interested in. And once again, please help us to fill out this survey and let us know how we're doing, what can we make better, and what would you like to see on future events and in upcoming events? What topics are you interested in? And that will help us out to provide you better options in future. And once again, thank you very much for joining us today. Thank you very much, David. Thank you very much, Peter. And
thanks everybody for being here.
Yeah, and this is the last webcast, at least in English, for this year. So thank you everybody for being here in the last session of 2018. Thank you, and I wish you have a great day. And we shall meet next time.